Question number 5. The curve C has polar equation r is equal to a cot a third pi minus theta, where a is a positive constant and theta ranges between 0 and a sixth pi. It is given that the greatest distance of a point on C from the pole is 2 root 3. So on A they say, sketch C and show that A is equal to 2. So when sketching the polar curve C, we can make a little table of values like this one. So we can have values that are ranging between 0 and a sixth pi at regular intervals. So these are values that are gonna help me to plot out or map out the polar curve C. Now substituting into the equation, when theta has a value of 0, you find that r will be having a value of 0.58a. And when theta has a value of pi over 24, r will have a value of 0.77a. When theta has a value of pi over 12, r will have a value of a. And when theta is a value of pi over 8, r will have a value of 1.3a. And lastly, when theta is a value of pi over 6, then r will have a value of 1.73a. Now with this table of values, I can consider a plane where I can plot out the graph. So I'm now plotting out my points. R values, when theta is equal to 0, r is 0.577, so I can put the point somewhere around here. And when theta is pi over 24, we have 0.77a, which is just below a, so maybe around here. And when theta has a value of pi over 12, then we have a as the value, so here. When theta has a value of pi over 8, that's 1.30a, so just outside somewhere here. And lastly, when theta has a value of pi over 6, then that's 1.73, which is maybe somewhere around here. So I think you can see how the graph is coming out to be like. So here we have the initial line where theta is equal to 0. And from the initial line, the graph seems to be going this way. So this is the graph. And the pole is roundabout here. Now the question also says it is given that the greatest distance of a point on C from the pole is 2 root 3. So the greatest distance should be the distance up to this point. So if we consider the equation r is equal to a cot of a third pi minus theta, then r will have a value of 2 root 3. That's the greatest distance, and that's a cot a third pi minus theta. So the theta value we said is a sixth pi. So we can solve for a here. So what I can do is I can say 2 root 3 is equal to cot is 1 over 10. So that's like a over, and a third pi minus a sixth pi is a sixth pi. So this therefore means that a is equal to 2 root 3 times 10 of a sixth pi. And we know that tan of a sixth pi is 1 over root 3. So it's like 2 root 3 times 1 over root 3. And this means that the root 3 and the root 3 will cancel out. And we have our answer as 2. So that's how we can prove. Let's go on to part B. So on part B, the question goes, find the exact value of the area of the region bounded by C, the initial line, and the half line. Theta is equal to a sixth pi. So in our case here, the area that we're looking for is this area here, bounded by the curve, the initial line, and the half line. Theta is equal to a 6 pi. Now, in order for us to find the area bounded by the graph, what we're going to do is use this formula here. So since in our case, we got A to be 2, the equation of the curve is 2 cot a third pi minus theta. Now, applying this into the formula for area, we say area is equal to, factoring out the 2, that will be 2 times the integral from 0 up to a 6th pi. Those are the limits of cot squared of a third pi minus theta. And that's with respect to theta. Now we can apply the identity cot squared plus 1 is identical to cosec squared theta. So that means that applying that identity, we'll be having 2 of the integral from 0 up to a 6th pi as the limits of cosec squared of a third pi minus theta minus 1 with respect to theta. Now we know that if we integrate cosec squared of a third pi minus theta, we are going to get cot as the integral. So that's cot of a third pi minus theta, and integrating 1, we get theta, and we'll be having the limits here, that's 0 up to a 6th pi. Now I can substitute a 6th pi. Let me scroll down first. So I can substitute a 6th pi into this. So I'll be having here 2, and substituting a 6th pi, we know that a third pi minus a 6th pi gives us a 6th pi. And cot of a 6th pi is as good as 1 over 10 of a 6th pi. And that's substituting a 6th pi on theta, that's minus a 6th of pi. And substituting 0 here, we'll be having minus of 1 over 10 of a third pi. And that's minus 0. So this is what we now have. So we can simplify this a little bit more. Okay, 10 of a 6th pi is like 1 over root 3. So 1 over root 3 is like root 3. So this thing gives us root 3, and multiplying it by the 2 that's outside. So we have root 3 here, and that's minus a 6th of pi, and that's minus 10 of a third pi is root 3. So that's minus 1 over root 3. So that's as good as 2 root 3 minus a third pi, and that's minus 2 over root 3. Now, simplifying this by rationalizing the denominator, it's like we have 2 root 3 minus a third pi, and if we multiply this by root 3 over root 3, then it becomes 2 root 3 over 3. And this is going to give us an answer of, if we say 2 root 3 minus 2 root 3 over 3, we know that's 4 over 3. So we'll be having 4 root 3 over 3, and that's minus a third pi. So this here becomes the final answer. Let's scroll down to part C. So on part C, the question goes, show that C has Cartesian equation 2 bracket x plus y root 3 equal to bracket x root 3 minus y multiplying root of x squared plus y squared. Now here, I'm going to write down the polar equation of the curve C. So that's r is equal to a cot theta. We got a to be 2, so that's 2 cot of a third pi minus theta. Now, what we're going to do here is I'm going to write it as r is equal to 2, and we know that the trig function cot can also be written as cos over sine. So that's cos a third pi minus theta over sine of a third pi minus theta. Now I can multiply both sides by sine of a third pi minus theta. So this 2 will cancel. And on the left side we'll be having r sine of a third pi minus theta is equal to 2 cos of a third pi minus theta. Alright, now I'm going to use the addition formula for these. Starting on the left side, it means we'll be having r sine of a third pi cos theta minus r sine theta cos a third pi. And that should be equal to 2 cos of a third pi cos theta, and that's supposed to be plus 2 sine of a third pi sine theta. So we can simplify this. We know that sine of a third pi is root 3 over 2. So that's like root 3 over 2 here, r cos theta. And that's minus, we know that cos of a third pi, that's like cos 60, which is a half. So we'll be having here half r sine theta. On the right side, that's 2 cos a third pi cos theta. That can be written as 2 of cos of a third pi is half. So we have a half cos theta here. And that's plus 2 sine of a third pi, which is 2 of root 3 over 2 sine theta. So here we can cancel out this and also multiply both sides by 2. So by 2, so they will cancel. Then by 2, then this will cancel. So this one by 2 and this one by 2. So we'll now be having on the left side root 3 r cos theta minus r sine theta is equal to 2 cos theta plus 2 root 3 sine theta. So this is what we now have. Now for cos theta, we can use this important result to say cos theta is x over r. So it's like we have root 3 r is x over r. And that's minus r of sine theta should be y over r. And here we said cos theta is x over r. And here sine theta is y over r. Alright, so we know that the r's will again cancel on this side. So on the left side we'll be having x root 3 minus y is equal to, and on the right side we'll be having at the top that's 2x over r, and that's plus 2y root 3, and it's all over r. So we can multiply both sides by r. So by r and this side by r. So the r's on the left side will cancel out, and we will have the left side as r of x root 3 minus y, and on the right side we'll be having 2x plus 2y root 3. Now using the special results, on the left side we can have r as the square root of x squared plus y squared, and that's multiplying the bracket x root 3 minus y, and that should be equal to, here I can factor out 2, so that's 2 of x plus y root 3. Alright, so what we now have is actually the answer, and we can write it down as required by the question in the order that the question gives. So it's 2 of x plus y root 3 is equal to x root 3 minus y bracket and the root x squared plus y squared. And that's the answer right here.